Hello, everyone. Today, we're going to talk about a very exciting topic. Well, at least a very exciting topic for me, how to run open source databases on Kubernetes. Now, before we dive into some specific tips, I want to talk a little bit about their big picture and how I see current situation from my standpoint of living and working in United States. Well, there is a lot of migration going on to the cloud, and especially proprietary cloud, where there is a lot of focus at using some very specific proprietary feature those clouds offers, which indeed bring a great usability, but also at a great cost, because you become really tied up to that cloud, and it makes it very hard to move to some other solution if you need to or choose to for any reason. And that is especially problematic for databases, which are typically some of the hardest to move around because, well, data is complicated. Now, though, looking at this environment, this reminds me when I started in the industry in the late 1990s or early 2000s. Now, obviously, with this being a virtual conference, I cannot see you, so I can't see how many do we have gray-haired engineers versus young folks in the audience. But for those who were in the industry in early 2000s, you may remember how we would have folks using proprietary platforms, for example, ones from Microsoft, who had those very nicely integrated graphical user interface tools, which they used, and, well, open source dudes would be using, DI to write PHP scripts, right, or Perl, or whatever your language of choice would be in this case. And that would be really getting chuckles from those people about how can you use so stone age technology when there is such convenient solutions coming from the evil empire, which was a nickname for Microsoft at that time. Now we know where that things changed. In the end, we had a lot of development ecosystem around open source build out, and now we have a fantastic development tools for open source platforms where those tools themselves are open source or not. Now we can see the same or similar situation with AWS and web services, where we see a lot of fantastic services which AWS offers, which are proprietary, and which I believe the open source would catch up. Another example may be learned in the operating system side. I also remember when I was starting for Linux in the late 90s, a lot of my friends were running real operating systems like Solaris or HPUX or AX, right names, which may, have nothing but historical meaning for younger generation of engineers. But at that time, those were the real thing, and Linux was a toy. It was 32-bit. It couldn't really run on the multiple CPUs well. Well, it could not even support file sizes of more than 2 gigabytes in size. Believe it or not, but that was a limitation at that time. But guess what? As open source slowly but steady grew and improved, Linux replaced Solaris as an operating system almost everywhere. And I wanted to share with you this picture to highlight why I believe that is now happening in the cloud environment as well. This is a picture of only part of a landscape of image from CNCF Foundation, which really shows really many hundreds of projects and companies in different stages forming that ecosystem, committed to building something which is really portable among this different clouds. And I think that is fantastic, because we are getting in the situation when we can give the cloud its originally intended role as a commodity infrastructure and really build all the value stuff on the Kubernetes and their open source software. Now, why do I call it this originally intended role? Well, Amazon used to talk about their cloud this way. Now, I took this picture from one of the older presentation of Amazon Web Services before people understood really what a cloud is. And what they were pitching in this case is analogy to electricity services. Well, it doesn't make sense for you unless you are in some very specific circumstances to produce your own electricity. It's much cheaper, more convenient, reliable, and so on and so forth to buy that utility power. And of course, that makes sense. But also what is not being told here is what electricity is commodity. It does not really require lock-in. You can change your electricity provider and that will be the same electricity. Or you can, choose to get a generator and create your own electricity and keep all your appliances. Your TV, your fridge are all going to continue to work. Where in the Amazon case, if you are buying that electricity from Amazon, like their compute, like what they're pushing you to, right? Not just compute services, but their, proper databases like DynamoDB, right? TimeScreen, right? Or all the other services. Well, guess what? They are only going to work on Amazon, and I think that is a problem, and that's something we want to avoid. But anyway, enough of that. Let's talk a little bit more about the Kubernetes and why the Kubernetes is so important. I love the Kubernetes is what it is universally available. It exists at every major cloud out there. You can run it on-prem, you can run it on the edge, you can run it everywhere. And what is interesting in this case is what Amazon was not somebody who embraced Kubernetes at first, right? They have their own container orchestration systems, which they try to really force you to use because that would create another proprietary solution for Amazon. But well, did not work out, and even mighty Amazon had to bend to the power of Kubernetes and start support that and their platform. Now, Kubernetes was created initially for stateless applications. And that is why many people even now would tell me, well, Peter, I understand for application and for other stuff, we're already using Kubernetes. But databases, no, Kubernetes is not designed for databases. Well, and I would say, yes, it wasn't. But as many things, it has grew beyond its initial founders' ideas and took a life of its own. And that life includes running a lot of data-intensive applications, including databases. And we can see that, though, before the Kubernetes operators became available for most popular open source databases. We can also see what were, over the last years, quite active community formed, which is focused on running stateful applications on Kubernetes, called Data on Kubernetes community. And you can check out the website if you like using this link here. At your corner, we are sponsor and active participate on this office of the community as well. Here are some interesting stats which I thought is interesting from their data on Kubernetes survey. Right now, what you can see here is what there are substantial number of people who are active in this data on Kubernetes community, already running some significant amount of stateful workloads on Kubernetes. Now, of course, I would take those results with a little bit of grain of salt, because if you do not use Kubernetes, right, or you don't believe in running stateful workloads on Kubernetes, probably you would not be a member of Data on Kubernetes community, right, and would not participate in the survey, right? But I think it's still interesting stuff. Now, the other thing is a little bit more relevant from my standpoint. This talks about, okay, if you are storing some data on Kubernetes, so data on Kubernetes ecosystem is relevant for you, what is that data? And we can see here what the databases are actually leading type of a stateful workload, right? So Kubernetes really gets a lot of attention as in its use of databases. Now, I mentioned already there is this concept called Kubernetes operator, which is how we like to run their database on Kubernetes. And you can see what a very large number of people actually use Kubernetes of databases specifically, right? And again, for quite a few reasons, and we'll talk about those reasons a little bit further on. Next, there is a value of operators, right? Why would you want to use the operator specifically to run the databases? And that is what a survey really tells. Now, what I think about the power of Kubernetes operators is this. Now, the databases are fundamentally different from many simple stateless applications. Where stateless application, you essentially can, just deploy it at any time, redeploy it from scratch if you have to. It can have a very simple life cycle, if you will. If you think about the database, though, it really requires a lot of care, because whatever happens, you need to maintain that data and actually changing that data, right? Like, hey, if you are, for example, making a bank transaction, you cannot lose that transaction and just say, oh, well, you know what? I restored you your database from 5 minutes ago. Here it is. It's good, right? No, it's not. If you work with the data, you not only need to persist with data, but also to ensure no changes to that data are lost. And that is a pretty hard thing to do, which requires a lot of very careful care, right? And that is what often human operators would really plan and execute some very specific steps to do various activities, like to upgrade the database and do a rolling restart so it always maintains high availability and never kind of goes down or loses any data, right? Or if something goes wrong, initiate a rollback mid-progress, right? There is a lot of moving parts, especially handling those various edge cases. And what the power of Kubernetes operators is what you can take all that kind of human intelligence, maybe many years of your experience, and actually program them using their Kubernetes primitives and approaches, right? And you think about the Kubernetes operators, they are really focused, of course, a lot of automation. And I think what is important, though, is this automation is both day one automation and day two automation. Now, day one automation is what a lot of people who are just playing this stuff are really focused about. Oh, look at that. I can deploy a 5-node cluster with just one command of kubectl apply. That is wonderful. But it is also like relatively trivial, because what is really complicated is all that things happening in day two, right? And they always happen, at least for production databases, right? You will have failures. You will need to do upgrades and patches. Some of them will go wrong and will need to be updated mid-process. You'll have backups and restores. You'll have cluster nodes or storage failing, and you will need to have a self-healing. All that stuff is something what an operator can do, and which just will not happen if you just deploy, a container and say Kubernetes, hey, please manage it. That's why I would recommend to use operators. Now, if you are ever wanted to play with Kubernetes operators, and in particular, this is example with MySQL compatible Percona XRDB cluster or operator, you can check out this blog post. I wrote it to show with a Minikube how easy you can do many basic things, provisioning, scaling, right? And if you were ever running Percona XRV cluster, right, or other cluster database on Linux with VMs, you probably will be dazzled and amazed how easy those operations are compared to many, manual commands on different nodes. You have to do that if you just, go with, classical VM automation approach. Now, maybe to convince you even more what operator on databases is doable and practical, I pulled out here some of their public cloud database as a service services, which have publicly spoken at one time or another what they are using Kubernetes underneath, right? So here is example, and in my estimates, that means what there are hundreds of thousands of a database nodes, right, which are running right now for various databases in Kubernetes, quite successful, right? And if you hear from somebody saying, well, databases on Kubernetes are not possible, you can always point to this example. Now, of course, that does not mean that databases on Kubernetes are easy, right? And if you can really put some mission-critical database on Kubernetes with no experience and it will just magically work. No, that is not the case, but those things are being done. With that, let us just jump to some of the best practices. So before that, I wanted to maybe cover a couple of general things. First, well, I am personally by no means their Kubernetes expert, right? If you hear something in this case which you find not a very good advice, or have some other content, what else you would like me to add when I do this presentation somewhere else, in the end of the slides, there are my contacts. Please give me feedback. I always like to make sure my presentations are getting better and more valuable. The second thing, I would give maybe a general advice about how to adopt and start running of databases on Kubernetes if you're not already doing that. Make sure in this case is to look for instant gratification and an easy database to start running, not something which is their most valuable. Like, oh my gosh, if you only get our mission critical database running on Kubernetes, wouldn't that be wonderful? Well, probably not, right? You don't want to get started out there. In my experience, the companies which adopt the database on Kubernetes best, they first start with a test and dev environment, right? Making sure for those when I need to deploy test databases, right? Or I need a database as part of my CI/CD pipeline. Kubernetes fits out very wonderful. And if in the early stage you make some mistakes and those mistakes, let's say, cause data loss, well, or downtime, it's not that a big deal, right? And then start maybe from a second tier, smaller databases until you are ready to run some larger database on Kubernetes. Well, and also, I would say not every database right now is feasible to run on the Kubernetes. The limit, what you can run effectively as the largest database size and the traffic in your, I would say, like a bare metal environment, is probably larger than what you would run in Kubernetes those days, right? So some things, yes, maybe you are not to migrate them, and that is possibly fine. It's not black and white. You can run nothing on Kubernetes, right? Or you're able to absolutely run everything. Okay, let's go to the best practices then. So number one would be to use the operators. As I mentioned already, right, that is something which really gives you the day two automation, right? If you just simply use, oh, I use, Helm, which deploys me, a couple of containers just and leaves them out there hands off. Well, that is probably not going to be a very good idea. Number two, you want to make sure you set up availability. And again, good operators, they should have that built in. You should be able to say, hey, I'm setting availability out there, so there is no single node of failure, right? That's maybe, both for the database node as well as for load balancer, if there is one deployed and so on and so forth, right? Well, the reason, of course, is what you can't really rely on a single instance in Kubernetes, right? Because it is possible, I don't know, let's say, pod needs to be rescheduled, that instance has to go down, right? Well, and for production, at least, you do not want that to be happening. Now, in Percona, in our operators, right, and we have operators both for MySQL, for MongoDB, and for Postgres, all of them support high availability out of the box. And even more, right, we really sort of require you to put operators in kind of like some separate unsafe mode if you want to really deploy them in non-highly available environment, because we want to ensure you really understand the risks of data loss you accept. The next one is you want to make sure what you're keeping your persistent data as a database persistent, and that means what you are really using persistent volumes for the data store. And in this case, actually, you can use both local disk or fast remote storage. Especially in a case that you have your Kubernetes environment well controlled. Local storage can be often very fast and very cheap, both if you set it up on-prem, right, or if you are using the cloud for that, compared to the fast remote storage. Though in certain cases you want to use that remote storage as well. But again, especially with that local disk, you have to plan for it possibly, going away, and make sure you have availability and setup so it does not really cause the problem. The next one is you want to keep the data per pod reasonably small. If you look at your big iron database, right, you will find people running 50 terabytes or more MySQL, Postgres, whatever databases those days. Well, that is probably too much to keep on the single pod, right? You probably want to go store hundreds of gigabytes, maybe terabytes tops per pod out there, and use some technology like sharding if that is available with a database operator you use. Because again, dealing with that large data set in Kubernetes can be more messy. Because, well, guess what? You always need to be thinking about what if I will have that automatic self-healing event, right? And that means, well, their node may need to, get that amount of data from somewhere, which obviously can take some time, right? And depending on how exactly that synchronization happens, it can cause a load on other nodes and so on and so forth. Another thing to consider is using appropriate node sizes. The thing here is what's on Kubernetes, as well as I would say in your classical on-prem bare metal or VM environment, databases often require larger VMs, larger bare metal compared to what you use for web apps, for example, because they may not be scaling out as easy. And if that is the case, then I really think that that through. I often see the mistakes when the Kubernetes itself is deployed on a smaller nodes, and that really limits a lot how much database traffic you may be able to handle with that. Next one is when you are looking at your database, look at resource configurations by placing requests and limits, especially on CPU, but also probably on memory. Well, why? Because database, if it's under load, it's going to be rather CPU hungry and rather memory hungry. What you want to avoid, of course, first is a database running out of memory, right? Because, well, it just didn't get that memory available where it needs to run, because it will crash, restart can take a long time, right? And that can all trigger all that messy work operator has to do, which is, well, handled, but not very well. And especially if you have like a multiple database nodes crashing due to out of memory at the same time, right? Because let's say load increases and amount of memory demands increases. That is not a good idea, right? That is why I would normally make sure you have a request of memory which is appropriate for a database configuration, right? What you deployed. Now, with CPU, it's also interesting. In many cases, when you don't put any limits, you may have a database has a pretty good performance, right? Being able to use all the resources available. But if there are some other tenants use that resource in other cases, well, those resources not available anymore, and database performance may be not uniform. In production, though, you want to make sure what resources available to database are pretty much fixed. If there are two dynamics, ebbs and flows, that makes it very hard to troubleshoot. Why is my database running slow? Is something wrong with the database, or is it just because Kubernetes has 1/10 of the normal resources available for it right now, right? That's kind of complicated, and in production, not probably something you want to deal with. Number 7, use proper anti-affinity. Well, as we already spoke, high availability is extremely important in Kubernetes, right? And anti-affinity is extremely important for high availability, right? Kubernetes has the same defaults in this case, right? But if you mess with them, you may end up in the configuration where you have a 3-node clusters, which all of them are running on the same physical node. Well, that is probably not a good idea. Or maybe all the nodes which are all in the same rack, which is on a kind of single power channel. Well, again, maybe not a good idea, right? You really need to make sure what the physical placement of those different nodes really applies to the goals you're having. For example, if you run in the cloud, we see some people making sure what you have a different nodes are provisioned in different availability zones to make sure if there is a full outage of availability zone in a public cloud, then your database cluster can survive it. Tune your database. Well, in this regard, there is no magic in Kubernetes. Kubernetes doesn't automatically tune to your database. Well, operator may or may not do certain additional tuning, right, compared to your sort of bare bones deployment, but I would think as if it doesn't, and make sure I apply proper database configuration. Of course, set up my proper indexes, make sure the queries are well optimized, same stuff what you really do with databases usually. And this is where I would encourage you to check out Percona monitoring management. That is an open source solution from Percona, right, which works both with databases deployed on Kubernetes as well as on-prem, and it supports MySQL, MongoDB, and Postgres and derivatives. Number 9, really understand how a database you're using can be scaled out. Because certain database technologies, well, from one Percona supports, that would be MongoDB, is relatively easy to scale out by deploying as many shards, right, as you need. Some others, such as MySQL or Postgres, they can be only scaled up, and also you can apply more read replicas, right, to handle your reads, right, in this case. But if you really need to handle more writes, well, you need to scale up, and that has certain limits. Now, of course, you can manually implement sharding, but that is an other story, right? And what the operator and the database technology can and cannot do, I think, is very important to understand to avoid running into trouble when you can't scale your application because, well, you just assumed something is possible, what is not. Next, the highlight would be to control the pod evictions with the pod priority settings, right? Well, the Kubernetes works this way. What sometimes pods need to be rescheduled, right? And that means they're essentially killed, maybe to make space for some higher priority pods. And with database pods, we don't really want to do that, because shutting down and restarting the database is rather expensive, especially for larger databases, right? So what that means is you often want to make sure all the database pods have a high priority in this case, so they are not tossed around, right, by some other pods which exist in the same Kubernetes. Many of our customers go even further, and the Kubernetes they use, a Kubernetes cluster for the databases, is isolated from other stuff. So it's more predictable. It's also often maybe using the larger nodes compared to the and different storage configuration compared to what the app needs. Number 11, do not expose your database unless you have to, right? Or only minimally expose it. The idea in this case is, well, if the applications talking to a database or run in the same Kubernetes cluster, well, don't expose it beyond it. If it's something which you have applications which are talking to a database from other clusters, well, you'll have to expose your database, but also make sure you have appropriate firewall controls yet, so it's not something where anybody from anywhere can connect to a database, because that is a huge security leak, and we had seen a lot of problems in the industry with folks either exposing their databases or often exposing their backups. With that, you also want to make sure you have a data at rest and data in transit are encrypted. Now, in the past, encryption had this notion of, oh my gosh, that is something very expensive. It will slow things down many times. Things have evolved since that, right? And modern CPUs, modern libraries, right, they really make encryption very cheap if configured properly, right? And I would encourage you to configure that, especially for sensitive databases, right? It's better be safe than sorry. Another good Kubernetes practice is to make sure you are using Kubernetes secrets to pass the database credentials to your application. That is a Kubernetes way, which is recommended, right? It integrates with various, so the solution as a backend for where those Kubernetes secrets can be stored, like such as the HashiCorp's wall, and it is much more secure than, let's say, hard coding passwords in the application, right, or passing them through environment variables, right, or some other stuff. Number 14 would be, do not forget backup. Now, it is important to note what, even if you have like a cluster, have 3-node cluster, 5-node cluster, well, it's 5 replicas. Well, of course, it's extremely unlikely what all of them are going to, like a crash at the same time, right? I don't need backups. Well, wrong. The problem with cluster is what you may have, programming error, or maybe intruder does some damage to the database, like goes ahead and drops the most important table, which guess what? Gets instantly replicated to their all the cluster. Well, and then if that happens, you want to be able to obviously restore to the point before that happens, and that is provided with some sort of backups, right? Not to mention there are some other disasters which can strike, right, which will require you to rely on those backups. Now, the good thing about the backups, the good operators out there make backup enablement is very easy, right? Much easier than setting up some scripts, putting them in a cron job, and yada yada, right? You may want in that kind of classical Linux VM stage. So, don't forget to enable them. Number 15 would be to consider new generation databases. Now, what is interesting in this case is if you think about the most popular open source databases, like namely MySQL and Postgres, they have been developed way before cloud, well, before even virtualization was a thing, right? And what that means is generally they are designed in this concept that you have a single large node, right, and maybe some, other large nodes as replica, right, or in a clustering situation, right? The new design cloud native, that's kind of encourages you to use the new approaches, right? Such as, hey, I have many small pods with a small data size, or even maybe concepts like a separation of a storage and compute, where I have my storage nodes and the compute nodes being separate, right? Well, there are databases being designed right now for this. Some of them, as VTES, are essentially like a proxy which uses MySQL and its foundations. Other as Neon, Yugabyte, TiDB, they are the essential databases designed from the ground up for cloud concepts. Right now, they are not as popular yet as those leading database technologies, but I would be very much watching at what's going on in this market, right? Because I think that Kubernetes is such a major shift in technology that it may require the full rewrite, if you will. Now, this is all about the databases and Kubernetes operators. Now, if you have some developers in your organization, you may also hear as well, those operators are quite fantastic, but they really don't give me this kind of database as a service experience, which I got addicted in my cloud. If Amazon Aurora or MongoDB Atlas, I can just deploy the database in couple of clicks. With Kubernetes operators, I can also do that, but I have to mess with YAML, right? And that's kind of completely different UX altogether, right? So what is possible out there? Well, At Percona, we are also, beyond our work on the Kubernetes operators, we are also working on PMM as being able to serve as a graphical user interface to be able to deploy and manage database as a service, right? Or basically with our operators. This feature is currently in technical preview, right? And I would encourage you to check it out and let us know what you think, right? Or maybe submit a patch or two, right? That is a wonderful properties of open source, where if something doesn't fit your needs, well, you can adjust it to fit your needs. To make it easy, we actually now enabled the free Kubernetes cluster, which you can get. You can use that free Kubernetes, right, and, to play with a database as a service in PMM, or also to deploy the operators, either ours or somebody else's, and play around with that. I think that's can be quite helpful. With that, it's all I had to say. As I mentioned, here are their contacts of mine, and if you have any feedback, please let me know. Thank you.